All right, so your first question here says, an airport runway. A pilot is traveling at a height of 3,500 feet above level ground. I think they mean ground level. According to her GPS, she is 40 miles away from the airport runway as measured along the ground. What's the angle of depression that she will need to look down to spot the runway ahead? So let's put her here in the airplane. Over here, this is the airplane. And she is at a height of 3,500 above. So this is 3,500. And
Okay.
she is 40 miles away. So there's 40 miles. Well, we should put that in the same units. So what is 40 miles in terms of feet? Let's do a little work here on the side.
Is it?
So we put 1 mile equals how many feet?
I'm trying to figure that out. Is that like? I know it's 5,000. Like it's like 52. Like 5260.
Let's ask Siri. Hey Siri, how many feet are in a mile? I want to say 5280. Yeah.
Okay.
5280. So that's our conversion factor. So we're going to multiply that by 40. 40 times 5280.
211, 200.
Yep. So that also will just give us a good idea of how far we should. So this is going to be a lot farther over here, right?
Yeah.
So that's the airport. And what angle of depression will she need to look down? So she's looking to spot the runway. So she's looking down like this. And this right here is called the angle of depression. That's what we're looking for. That's the angle of depression, right? Which is the same as the angle of elevation from the opposite side. So we could call that theta as well, because those are parallel lines.
Okay.
So this is a right triangle. So we can use SOHCAHTOA because SOHCAHTOA uses right triangles. And SOHCAHTOA, what do we have? We have the adjacent
and the opposite.
And the opposite. So we're going to use what?
Tangent.
Perfect. So the tangent of theta equals the opposite over the adjacent. So how do you solve that?
You just will plug it into the calculator.
Yep. And with the tan inverse, right?
Oh yeah, it is the inverse.
You're gonna have to use the tan inverse of that. We can just I don't know. Well, yeah, we can. We can call it 35 divided by 211.2. We can do that.
Yeah, I know.
So tan inverse is second tan 35.
Oh, that's also tan inverse?
Yeah, that is the tan inverse.
You're just having us use the x to the -1 right underneath the math. That's even easier.
Nope, that won't work. X to the -1 is like 1 over x. So that wouldn't work. The x to the button under the math button is not the tan inverse. So that would not have worked. So your mode, let's make sure we're in degrees or radians. We're in degrees. Yep, perfect. So that's 9.4 degrees. And that looks about right. You know, it's going to be a small angle because that's much longer. That bottom side is much longer than the other. Okay, see how that works?
Okay. Yeah.
Questions about it?
No. On that one.
All right, you have another one?
Yeah, I put one on the second page.
All right, from the top of a 100-foot building, a man observes a car moving toward him. The angle of depression changes from 15 to 33 degrees during the time period. How far does the car travel? Okay, so he's on top of a 100-foot building. So that's 100 feet right there. He's on top of the building right here. And it changes from, well, this is a little bit tricky. How tall is the man? But I assume we don't have to worry about that.
Yeah, I just assume that also.
So let me change the picture. Let me say that he's laying down like this, looking.
Okay.
He's like being all stealthy, and he's looking. Uh,
Yeah, that's
observe
probably what you
a
thought.
car
That.
moving toward him. So here's the car in position A, and here's the car in position B. And position A, that angle right there. And position B is that angle right there. So the angle of elevation, remember the angle of elevation and the angle of depression are the same. So these are my two angles here. It was 15 degree to start, and then it was 33 degrees at point B. Okay.
Okay.
So how far does the car travel? So they're asking for this distance right here, right? That's how far the car traveled. That's your X. See how I came up with that?
Yeah, so I'm guessing we have to find the for both of the angles, we got to find distance for both of them, and then subtract A from
Yep.
B.
Yep,
Oh.
absolutely. Yep, that would be the easiest way to do it probably. So this distance, we'll call this distance D2, and we'll call the full distance D1, your first distance.
Okay.
So D2 is from here to there, and D1 is D2 plus, basically plus X, right? That's D2 if you add it all the way to the A. Okay, so what would our formula be? We just talked about, right, the tangent.
So you got the opposite, and then you got the adjacent. So yeah, just be
So the tangent of 15 equals
100.
the adjacent, which is D1,
Oh,
right?
yeah.
I'm sorry, D2. No, that was D1. I wrote D2. It should have been D1. Our first distance, where it was at the beginning, is longer, right?
Okay.
So
Yeah.
it's whatever D1 is divided by 100. It's the, oh, sorry, I did that wrong, didn't I? Tangent is opposite over adjacent. My fault.
All right.
So you were saying that actually. So it's a 100 over D1.
Okay.
Right? I think that's what you were actually saying.
Yeah.
Which means D1 equals, if I multiplied it over and then divided by tangent, D1 is 100 divided by tangent of 15 degrees. So 100 divided by tangent of 15. Again, make sure you're in degrees. It's 373.2, let's call it. 373.2. We'll round to, I don't know if they told us to round, so we'll round to 100 or to tenths.
All right.
What's the other formula?
And then it would be tangent of 33. And then it's going to be 100 over D2.
Perfect. So D2 equals what?
100 divided by tangent of 33.
And did you get that already?
Yeah, that would, hang on.
153, 154.0, let's call it.
Yeah.
Okay. So what is your X?
That would make your X 219.2.
I assume you subtracted those.
Yeah, I did 173.2 minus 154.
Perfect. There you go. And that's your answer.
All right. Then I'll add
Okay.
I got another one.
Yeah.
Go and add that. I just pulled up the online PDF that she gave us before this. So
Perfect.
it's easier to just
Perfect.
copy and paste it that way. Because then they come out a lot clearer.
Yeah, that's a good way to do it. All right, let me see you try this one. Do you have a way to write on this board?
Yeah, I can just use my mouse here. Right, 100 point on level ground, 125 feet. Passenger compartment elevation changes from 192 to 31.7. How far does the hot air balloon rise during this period? Okay, so it's rising straight up and down. It's from a point on level ground 125 feet from the point. So I'm guessing that the hot air balloon would be like this. And then okay. So it's actually rising during this.
Right. So it says from a point on level ground 125 feet from the point directly under the passenger. So you want to give it a shot at drawing the picture of that?
Yeah. So I think that you would draw the photo kind of like that. I kind of drew it a bit too big. Sorry.
Yep.
And then
That's all right. Here, I'll fix your angles of elevation.
Yeah. And this is your yeah, it's kind of hard drawing on a computer.
So the point is the same. That point is the same. That point doesn't change.
Oh, right, it is actually.
Right? So your balloon, the balloon is changing. That's the starting point of the balloon right there. And this is the ending point of the balloon right here.
Okay. All right, so I believe you got just one angle. Yeah, I think that those are your two angles, if I'm correct.
Let's see. Which angle would be bigger of those two?
The top one would be, because it's rising from the 19.2
does that make sense does it make sense that one would be bigger? Here, let's draw them a little. Let's draw them a little further apart. You kind of have to use a little bit of like just thinking like thinking with some common sense. Which angle looks like it's going to be bigger? Is this angle going to be bigger, or is this one? As this gets bigger up and it's going to the same point, what's happening to that angle at the top?
It's getting narrower. So this one would actually be getting narrower.
So that they're actually going to be flipped.
Okay. And did I do them on the correct side, or would they be down by the angle?
You know what? Yeah. You did it on the wrong side. I was going to say they list it in a different order. So remember your angle of elevation is the same as the angle of depression from here. So you could have drawn it like this, right? And that's your angle of depression. Your angle of elevation is down here on the bottom. So flip those.
Okay.
Now on the bottom, obviously, the bigger one is this one. And the smaller one is the one. So the angle of this angle, the angle of depression, you were drawing the angle in here, and I wasn't thinking that you were drawing that wrong. That's why I was using that example. But for sure, this angle is going to be smaller than this angle.
Okay.
So that angle, you can see them down here. It's the angle of elevation as well. That angle of elevation and this angle of elevation, obviously that one's bigger. So your 37, I'll circle this in red, is that full angle. And your 19 is this angle right here. Can you see that?
Yeah, I see that. So then you're gonna wanna. Oh, I actually got to do. I have one more value that I can add. would be
So what's the 125 feet? Where is that distance?
I believe it's actually down here. The 125 I think
Yeah.
is like right there.
Yep, that's right.
Set labels to that. So then these angles are actually the adjacent, and you're looking for. You actually would use tangent again, I believe.
Mm-hmm. So we're looking for what value are we looking for? Show me on the graph.
So we are looking for this value first, and then we're gonna look for this value to figure out ultimately this value right here.
Perfect. You got it. You got it. Remember, I changed my picture a little bit, so it's actually this value down here. There's the balloon at the bottom.
Okay.
Okay. So let's see it. Let me see you write out the equations.
All right. So then it's gonna be right. So I believe it's gonna be is it gonna be for the first one 33 tan 3 tan I gotta erase this. It's really weird writing on a mouse.
Here, you tell me what to write. How about that?
All right.
I'll write it.
I believe it should be see 33 tangent 125. I mean
30.
wait, yeah, 33 tangent, and then it will be D1.
Where are you getting the number? Where are you getting 33 from?
I mean 31.7.
Oh, okay.
Sorry.
Well, first of all, that's the angle. So we're gonna write it. I'm gonna do the blue one first. Okay.
Okay, so
Smaller one.
that would be 19.2 tangent. Well, tangent of 19.2
There you go.
equals.
There you go. Equals.
And then that would be distance. That would be the distance 1 over
We'll
your
call that
adjacent,
X.
which is 125. So yeah, X over 125.
Perfect. So tell me what X equals.
X would equal 125 times tangent of 19.2.
So that's 43.53. And what's the red equation gonna be?
So basically it's gonna be tan of 31.7. Actually, would it be? Or do you actually have to do
Sorry, I'm trying to
yeah,
figure out, call it Y.
okay. Yeah, it's 31.7. So it's gonna be tan of 31.7 equals equals Y over 125.
Perfect. Tell me what that equals.
So it's gonna be 125 times the tangent of 31.7, and you get 77.2. And then if you're rounding to 2, it'll just be 0.20. Yeah.
Good. And when you subtract them,
You get 33.67.
so this is Y minus X, which is 32.67. Very good. Perfect. And these are feet. We're in feet. Awesome. Good job.
All right.
Got another one for us?
Yeah, I'll go and copy that one over quickly. Let's see. Number 4. That over. All right.
All right. Go ahead and draw out the picture and then tell me what to write, and we'll write this equation together.
All right. So a flagpole is situated on top of a building. The angle of elevation from a point on level ground. On level ground, 330 feet from the building is to the top of the flagpole is 63 degrees. The angle of elevation from the same point to the bottom of the flagpole is 53 degrees. Find the height of the flagpole. Okay. So you got your building here. And then on top of the building, you got a flagpole. And then, so the angle of elevation will be down. Actually, I'm gonna draw this a bit up
Mm-hmm.
just because I gotta write
Good.
underneath it.
Oh, that's good.
Okay.
Doesn't matter. You can write on top of it or whatever.
So yeah, and then this is actually I'll just use a text box for this.
Yep. I'll write it. 330.
Yeah, it's 330.
330 feet. Okay.
So
let me help you draw the lines because it's probably easier for me to do
yeah,
it.
so in the bottom of the flagpole, that line. So the top of the flagpole, the first angle is going to be 63 degrees. And then from the
Okay.
bottom, that will be 53 degrees.
And again, what is the angle of elevation? Here, let me redo that one in a different color so we can color code these things. Okay, so angle of elevation, remember, it's this right here. It's the same as the angle of depression. So that angle is the same as that angle. That's your theta 1. And then the red one, that angle is the same as this angle down here. And we'll call that theta 2.
Okay. So then theta 1 is going to be 53 degrees. And then theta 2 will be 63.
So we'll call this H1 up here, or H2, sorry, H2.
Yeah.
And we'll call this H1 right here. So let's go with the blue equation first. Tell me what to write.
For the blue equation, you would do 53. So the tangent to 53 equals H1 over 330.
Perfect.
Is it gonna ever be anything besides tangent?
They could have asked what the sight line was. They could have. They could have given you that sight line instead, right? So yeah, it's possible.
Yeah. Okay.
But typically, you typically use tangent for these because usually you're solving for the vertical and horizontal, right? Which is the opposite of the adjacent.
Gotcha.
So usually for problems like these word problems, it'll be tangent. I mean, they could have told you he measures the distance with a GPS device, like that's possible to try to find out how, like, he could have given you this distance right here by using some sort of GPS device to find that actual distance away. And then they would have said how far, maybe he knew how tall it was. He wanted to know how far away it was, maybe. I don't know.
Okay. So then, that's
So what?
330 times.
Okay. And what was the number you got? I'll trust you.
Tangent of 53. That I got 437.92.
Okay. And then how about the red equation? What's that going to be?
That would be the tangent of 63 equals H2 over 360. I mean 330.
Mm-hmm. And what does that equal to?
That equals 647.66.
All right. And when you subtract them, what do you get?
You get 209.74.
Perfect. And again, I'm just going to go ahead and trust you because I think you did it all right. Awesome. Good job.
And then
Time for one more, probably.
Yeah, we probably have time for more. All right. So, two observers on the ground are looking up to the top of the same tree from two different points on the horizontal ground. The first observer, who is 83 feet away from the base of the tree, looks up at an angle of 58 degrees. The second is only standing 46 feet from the base of the tree. And you can ignore the heights of the observers.
46. And what's his angle of
The
elevation?
other, his angle of elevation, the other one is, let's see. So first observer is 58. Oh, it does not say the angle of the other person.
Okay, so that's probably what we're going to try to find.
Yeah.
Okay, so if this is 58 degrees and 83 feet, here's the tree, and we're going to from two different points, looking at the top of a tree. So here's my tree. There's the distance away from the tree. There's that distance away from that tree. Right, and so they're probably going to say, fine, how well, a couple things. How tall is the tree to the nearest foot? So that's the height. We can find that using what?
We can find that using tangent also.
Tangent of, tell me what's right.
It would be tangent of 58 equals, we'll say, h over 83 feet.
Perfect, good. So
it's gonna be 83
so it's 83 times the tangent of 58. Excuse me, 58. 132.83, let's say. Pretty tall tree.
Yeah.
Very tall tree.
Yeah.
And then the next question is at what angle of elevation must the second observer be looking up at? So they're asking basically for theta. So we can find that by doing what?
Just you could do the tangent of 132.83 over 83.
Nope. The tangent of theta equals 132.83 over 46, not 83.
I mean, over 40. Oh, right, because he's only 46, not 83.
Yeah, we're looking at the blue triangle now.
Okay. Oh.
And then how do I solve that? Remember what I had to do? Theta equals, I had to do that tan inverse thing.
Yeah. So
not the x to the -1, the tan inverse. So I do second tangent, which gives me the tan inverse. Let's see if what you're saying is your teacher said you could do that. And see how that doesn't work.
Well, what you would do is you would close the parenthesis, then do the -1.
No, I don't think that would work. I don't know. Maybe it would. I've never done it that way.
Here,
it's a different thing. To do that is a different thing. I don't know. Let's test it. Let's see. 132.83 divided by 46. So there's the answer. Now let's see if we did tan of 132.83 divided by 46 to the -1 works.
no, it doesn't.
That's not the same thing. That's just not. Yeah, that's not it. There might be some calculators where you would use that function, like you would hit the tan button and then you would hit that button, maybe. But see how that doesn't work for this, because it doesn't give you it's trying to take the reciprocal. What this last thing is going to do is it's taking the reciprocal of the tangent. Like if I take the tangent of 132.83 divided by 46, and then I take the reciprocal of that, I divide that by 1 divided by the answer, I'm going to get that number. That's what x to the -1 does. It just takes the reciprocal.
Gotcha.
But tan inverse is a totally different function. The tan inverse function means what angle. This is literally what this means when you see this. It means right here, it means what angle has a tangent of this. That's what that means. What
Okay.
angle has a tangent of that over that? So it's a totally different thing.
Yeah.
Okay.
I probably just misheard her then. I'm
Yeah,
guessing.
you probably did. Or like I said, maybe certain calculators or certain websites, Desmos, I don't know. But I doubt it.
Yeah.
I kind of doubt it.
Yeah, it's probably
Like
just
maybe an old school calculator, a really old school, maybe there's that's the functionality that it somehow does, but I kind of doubt it.